Today we're going to be using HTMX to perform AJAX requests, which will allow us to update a list of structs in our browser without having to do a full page refresh. Our current program contains a single main package with a shark struct defined at the top, which has a species string and a population int field. And then we have our home handler, which is just rendering a single HTML template, as well with a partial template, which we'll show in a second. And then there's a data map of string keys with any type values. There's a title key that represents the HTML title of the web page. And then there's a list of shark structs, which we have defined here just with sample data. And then we're going to execute the template, and if there's an error, we're going to panic. Again, panicking is only for demo purposes. You normally don't want to use this in a real application. And then we have our main function, which is defining a router to a new servmux. And then we're going to simply have a home handler at the top level root route. You can see this special syntax in Go that's making sure it's not a wildcard route. And then we'll have a wildcard route below it for our file server of our assets. And for that, it's just a single shark image that we're going to display in our browser. And then we're simply running it on all interfaces on port 8080. And again, panicking, but that's only for demo purposes. Now, if we go and look at our HTML files, you'll see we have just this simple home page. It's saying welcome to SharkBite. We have an image being displayed, a form that we'll use to submit a new shark to the list of sharks, then a list of sharks, which is being populated by a range block over the struct of sharks that we pass in from our data object. As you see here, our data object contains these 4 sharks, so we should expect 4 sharks in our HTML output. And you'll see for each shark that we're iterating over, there's a block of a shark partial template being rendered. And if we go and look at that partial templates, we'll see it just defines a shark block. And inside that, we're just outputting the species, the population, and then a horizontal divider. Again, this pertains to the species and population fields in the shark struct. Now we'll run this server, and then just for reference, I have Go version 1.23.2, and I'm using the latest routing updates. So we can go over to our browser and visit localhost 8080, and you'll see our application is there. So you see the list of sharks is being correctly populated from our structs we're passing in as data. And then we have a form that's performing a post request action, although it won't work because we haven't defined the action in our code yet. For example, we can add a leopard shark with a population of 100. If you click submit, we'll see we get a 404 page not found, and it takes us to this shark route. That's because we have not defined the shark route yet. So we can go back to our application and define this, but first we're going to add HTMX. And so to do that, we'll just visit the htmx.org site, and we'll scroll down here and copy this script, and then put that at the top of our HTML. So below the title tag, I'll put the script, and I'm just going to add a defer tag. All defer is doing is essentially waiting to execute the JavaScript script until after the document has been parsed. So it would be similar to reloading the script at the bottom of the body. However, I like to keep all my scripts in my head tag just to keep them organized. As you can see, we have this method of post to the shark action, so we need to define that. And now that we've added the HTMX, we need to also update this. So we actually won't need these specific attributes anymore. However, we will still need the shark route, so let's go and define that first. So we can go to our main.go file and add a router.handlefunc to the post of shark, and we're going to call it shark handler. Now, as you can see, we need to define a shark handler as well because it's undefined. So we'll go here and say shark handler. We'll take a response writer and a HTTP request. And then we're going to set species to equal the form value of species and population to equal the form value of population. As you can see, form value is returning the first value for the named component of the query. And if we go back to our form, we'll see we have the name is population and the name is species. So that aligns with our form value strings that we're passing in. As you can see, our shark struct requires an integer for population. So we're going to convert population to a integer as well. We'll just do some error handling here. Check if errors nil and panic. Again, you wouldn't want to panic here. You'd want to return this as an error to the client side most likely. And then we can define a new shark struct, which we're going to set to the species and population integer that we just parsed from the form values. And now with the shark struct defined, let's think about what we exactly want to return from the shark handler post request. If we go back to our home.html file, you'll see we're iterating over the range of sharks, and each of those is going to have that shark partial template. And so if we want to append one to the end of the list, we simply want to add one more of these partial templates. So that's what we should be returning from this shark handler post function. So we can simply define a template, and we're going to parse the file of the partial template. So we'll do html/shark.html because that's our partial we're trying to return. Now all we need to do is execute and return this template fragment. Instead of using the execute function, we'll use the ExecuteTemplate function, which accepts an extra name parameter as a string, and that's just the name of the template that we're going to be executing. Again, I'm just panicking for demo purposes. So this should essentially take this shark partial template, pass in our shark struct that we just created here from the form value data, and then return it. So we can restart our server to test this out, go to our browser, and then back to our form, and we'll just say test1. As you can see, we're getting just the partial back now. If we just view the page source, as you can see, it's just the tags that were defined in the partial of our shark.html file. With that working, now we can consider how we can use this to update our list of sharks on our homepage. Our goal is to do this without requiring a full page refresh. This is where the power of HTMX comes in, and we're going to use it by converting our form to perform a simple AJAX post request and then appending that AJAX response to the end of this list. So let's go back to our code now and define that in the HTML. The first thing to change is the form attributes. The action and method are no longer necessary as HTMX has its own attributes that we can replace this with. So we'll change this to be an HX post to the shark endpoint, which is the same as having our action with the method, except now it's performing an AJAX request. Next, we want to define a target. Now this is still going to return that partial HTML response that we just got, and normally it'll swap the HTML of the inner element by default. However, we don't want to get rid of the form. We want to add this to the end of this list. So we need to define a HTMX target. So we'll wrap this in a div with a shark list ID, and then from there we can specify the target attribute to be shark list. So now it's going to replace this div's inner HTML with shark list. However, we don't want it to replace this entire list. We want to append it to the end of the list. So to do that, we can do hx-swap, and we can use the before end value. And what that means is that it's going to insert the HTML response after the last child of the target element. So if we look at the shark range block and see that it's just rendering these partials, this is exactly what we want, because it's going to first render all of these predefined shark structs that we have here, and then it's going to append whatever we specify in our form afterwards. So it will simply render it just at the very end before this div closes right around here. Now let's go verify this in our browser. So we'll restart our server, go to our browser, and we should expect this all to successfully work now. So we'll just clear out the form, refresh our page, and we'll define a leopard shark with a population of 100. And we should expect this now to be displayed underneath the hammerhead shark. So we click submit, there we go, it's working successfully. We'll inspect now our network tab just to see again how this is working. And we'll just add another shark with 200. And you'll see we submit, it gets populated there, and you can see the post request returns a 200 response, but there's no full page refresh. That's because HTMX is now using AJAX to update our page. If you look at the response from this shark post request, you'll see it's just the simple partial that we rendered even before we added HTMX. All HTMX is doing is simply augmenting your HTML and web page to become more SPA-like without having to add all the complexities of JavaScript. And I think that's one of the main selling points of HTMX is it allows you to perform AJAX requests and make pages seem just as dynamic as single page applications without all the complexity of the JavaScript ecosystem. However, I still think there are very useful cases for single page applications. It's more depends on what your application needs and how much reactivity you want. although I think HTMX is a great solution for internal applications or anything else that doesn't require that much reactivity or has a simpler UI. Now, this was a basic example of using HTMX in Go. There's a lot of more applications, and HTMX is a very powerful tool with a lot more features than I described here. But I hope I gave you a good glimpse into what is possible using that technology. If you have any questions, feel free to leave a comment. And if not, I'll see you in the next video. Thanks for watching.